Okay, this video is mainly about this idea of conformable matrices and matrix multiplication. Before that, a couple of miscellaneous but important things. Just would like you to note at the top left of the screen there, we've got up here, we've got A plus this thing equals that thing plus A, and it comes out as just A. That thing, if you look up, is a matrix with every element as 0. We call that quite predictably the zero matrix, and it has that a property which will become more useful to you once you get into matrix proof. So A plus 0 equals 0 plus A equals A. So it's looking like maybe matrices could be conformable for addition. Remember that word, conformable. Commutative, sorry, not conformable. Commutative means the order of the addition doesn't matter, but more about that later. So A plus 0 equals 0 plus A equals A. So you can see why that would be, because we're adding a 0 as we add each corresponding element together. The next one, we've got a matrix plus another matrix. The result is 0. If you look closely, we have 3 here and negative 3 here. We have negative 1 here, positive 1 here. So you can see that the magnitude of each number is the same, but the sign is different. So the polarity of each number is different, opposites. They unsurprisingly, when we look at all those real numbers, it comes up zeros. So we have a 0 matrix. So if we call that first matrix there A, this one would be negative A, because it's negative 1 times A, just like we do with real numbers. We could reverse that order, because it looks like matrices are commutative if they're the same order. Commutative for addition, we get the same result, the 0 matrix. Further down here, we've got the question that we had early in the course, this one here. We had a grocery list, 2 loaves of bread, kilo of butter, 6 eggs, 1 carton of cream. Cost of each grocery item is listed there, and in particular part C there, what is the significance of that calculation? And we're going to see that that's the total bill. The process that was used is actually matrix multiplication. We can see a very simple example here. Matrix multiplication happens when 2 matrices are multiplied together, unlike multiplication by a scalar, which is a real number times a matrix. When we have matrix multiplication, we have a matrix answer. So the matrix answer has a certain order. In this case, it's a 1 by 2. The 2 original matrices were a 1 by 3 and a 3 by 2. We have to note very carefully that for them to be able to be multiplied, the 2 inside numbers here, when we list the order, must be the same. The 2 outside numbers tell you the size of the resulting matrix, or in other words, the order. We have a row by column format. So the row, we go along the rows of the first matrix and down the column, or the columns of the second matrix. So in order to do this, please note there is a second video which shows it in more detail and shows more difficult examples. Before we do that, this idea that we just talked about where the 3's are the same, that's called conformability. Matrices must be conformable in order to be multiplied. Just as there were rules with addition of matrices, like they had to be the same size, the same order, we can multiply matrices that aren't of the same size or the same order, but the 2 inside numbers here must be the same. Let's have a look at how it works. And just remember, the next video shows this in more detail, video number 2. But first thing we do is go 2 times 2.65 plus 3 times 1.55 plus 1 times 2.35. And if you look at that, you'll get the answer 12.3. We've also got a situation where we have the second element. This is achieved by going 2 times 2.25 plus 3 times 1.5 plus 1 times 2.2, add it all together, you get 11.2. Perhaps now you can see that that is an example, earlier on was an example of matrix multiplication, because we have a row times a column matrix, and that matrix that you would have written here back in part A, a row matrix would have been 2, 1, 6, 1, and that is a 1 by 4. The column matrix of these values here would have been 1.95, 2.35, 0.15 and 0.95, and that would have been a 4 by 1. So we have a 1.4 times a 4 by 1. Sorry, that's a very squished up 4, but they're the same. And we have a 1 by 1 answer, because it's a single numerical answer, which is the bill for those groceries. Okay, so more about that in the next video.